That's perfect.
Thank you.
Just looking to see if we've got many people back. Seems like people are coming back to their screens, so thank you very much. I'm just chairing this next bit of the session for anybody that wasn't here at the beginning. I'm Rebecca Packwood and I'm the Chief Executive at PSPA. And we've got three speakers for this next session. I'm delighted to start with Professor Chrystalina Antoniades, who's the Associate Professor of Neuroscience at the University of Oxford and is also the head of the Neurometrology Lab. Chrystalina is going to be giving us an update on the OxQuip, the study today, which is part of what she does. Mostly she's focused on accurately and objectively measuring neurological disorders such as PSP and Parkinson's as well. So Chrystalina, as with the sessions this morning, will take the questions at the end from the Q&A box, if anybody can put them in there, and I'll try and get us through those in the session. So over to you.
Sounds good. Thank you very much. And great to see everybody here today to be discussing the work we do and NORAPS, for instance, which I'm very happy that you've heard all about it. And I have a slide at the end, but I'm glad Dr. Darkin has helped in sort of explaining it all. But if anybody is interested, do let us know. We've just opened the site in Oxford. I'm very happy to be discussing with any interested patients. So it's a great pleasure to be here today to update you on our work. One of the areas we're working here in Oxford is really to develop biomarkers. By that I mean tests, which sort of span within a number of different neurodegenerative conditions. And one of the special interests I have is PSP. Today, I'd like to tell you a bit about how I've been trying to quantify, how I've been trying to measure PSP using digital technology to help us record things like your cognition, gait abnormalities, so how you walk, your posture, and how really that complements nicely some of the standard clinical rating scales. For instance, all the questionnaires or all the questions and the tests that we ask you when you come to see us in clinic. So the data that and the results and all the work that I'll be showing you in the next little while is part of the OxQuip study, which I lead here in Oxford. And this is short for Oxford Study of Quantification in Parkinson, where we've been measuring subtle abnormalities in the timing, in the speed, and in the coordination of a number of the patient's movements. And let me just tell you very quickly why we've been doing this and how we've been doing this. So the reason why is primarily that we've been wanting to find an early signal. What we mean by that is that anything that has changed at the earlier stages or as early as possible, if that's possible, and see whether we can develop tests that can pick up these changes. And those tests that don't pick up the signal to sort of drop them at early stages and then sort of move on into something else. So just to walk you through the slide, I hope you can see my cursor. On the bottom left-hand side here, you can see a device called the oculometer. This is basically a very clever device that can measure how your eyes are moving. You can see three lasers here. I'll show you in the next slide a quick video of what it looks like to do that in clinic. We've got two very small infrared cameras. This is all non-invasive. There's no pain involved or no discomfort. It's attached around your head and you can measure within 5 minutes. Now we've sort of narrowed it down to even 5 minutes to see whether you can follow a dot and if we can pick up any changes in the speed of, for instance, of your eye movements. We've also been looking into your hand tapping, so how you tap from side to side, the speed of that, the pattern as where you do it, and so on. We've been using different technologies, such as the one that the patient is wearing here on the finger when we ask you to do some tests in the clinic. And again, this is giving us interesting data that we go back and think and look and analyze very carefully, but also things like this cognitive tablet where we ask you to think, and after we ask you a question, we ask you to sort of get this pen and do it on a tablet, which has made it much more easier for our participants to do. And definitely, last but certainly not least, all the different wearable sensors, such as, for instance, I don't know if any of you are wearing any smart watches today that we've been using to track how your movement overall is. So let me show you what some of these look like in clinic. Here is one of our lovely patients who has given consent to show today, and how we measure eye movements in clinic. So this is the system that I showed you earlier. It has 3 lasers that you can see on the right-hand side that are just very simply projected on a wall. It's just a red dot. All we ask you to do is sit there, wear these, and just follow the dot as quickly as you can from side to side. All this information is coming down to a small monitor that you can see me holding here. And I can see whether you are performing the task well, whether your eyes are moving satisfactorily. And then when we download all the data, we can have a look and see what happens with that. On the other side, if we move away from sort of the eye movement test, we also look at how you move in general. So here, Lily, one of our lovely PhD students, is wearing 6 sensors on her body. Again, all of this is non-invasive. It's just placed on your body externally. So you can see a chest sensor here. There is one that is worn like a belt at the back of the lower of the back of your spine. You have 2 on each, one on each arm and 1 on each foot. And this makes 6 sensors, essentially telling me what's happening when you are walking, for instance, how you can see Lily here doing the 2-minute walk, how you're behaving and how your movement is when you're doing a timed up and go task. So get up from the chair, turn around at the end of the clinic room, and then come and carefully sit down. And then how you stand with your eyes closed for 30 seconds, and whether there is any sway, that we know that in some of these neurological disorders there is sway, and how this can get exacerbated if we ask you to close your eyes, and how different that is from people who don't have neurodegenerative conditions such as PSP. So we do this, and it takes probably less than 5 minutes altogether. So it's a very easy way of looking at your movement and measuring it as accurately as possible. Just for people who might be interested to look at what some of the data looks like, don't worry about the details of this, but just to show you, there's a lot of data that comes out of these digital devices, and one has to be really careful how we interpret the data, what the data means, and whether it's helpful in the larger scheme of things when you look at their clinical scoring as well. And just for those of you, because people usually always ask me when we give talks like this, what do this data look like? Just to show you, this is data only from the left watch of that individual that I showed you in the previous page. And this is someone walking for 2 minutes on a straight line in a large corridor that we have dedicated here for such clinics. And all the shaded areas are when each one of you will be turning around 180 degrees really, to just come back to, continue walking if you like. And you can see all these zigzag lines are very, very important data for us that can help us understand what's happening when you're turning, what's happening when you're starting, what's happening when you're starting to get tired, and so on. And also when you're standing with your feet separated for 30 seconds, again, we can see if you're starting to sway, if that becomes worse when you close your eyes. And again, all of this data is proving tremendously interesting and important in when we try to see if we can follow you much better and much more accurately using this wearable technology. So just very quickly to show you 2-3 sets of our data. We've got lots of work ahead of us. We haven't finished looking at all the data, but just to share with you what we have published up to now. We know that clinical skills, and by clinical skills, again, I mean what happens when you come to clinic and your clinician is asking you to walk, to get up from your chair, to perhaps do some tapping, go through your clinical history and ask you lots of questions. They're very helpful, these questionnaires. And in fact, what we have shown is that within 6 months, don't worry about all of this, it's just to show you how much data one can get. But within 6 months, we can pick up a significant change in how someone walks, for instance. And this is the data. I'll get you to focus on this little graph on the bottom right-hand side called J. For those of you who can't read it, it's just measuring how someone is walking. And that's based on the clinician's sort of input with the scoring of different numbers. So the clinical examination and these clinical skills are indeed helpful in this instance, but the problem is that they're not very sensitive, and they're not very sensitive to small changes over time. And that's where we decided to start using digital technology to see whether that would be helpful. So one of the first sort of things that we found was when we tried to see whether we can discriminate PSP from Parkinson's disease, idiopathic Parkinson's, which we know that can sort of be confused for some of the cases for a few years. And we use this wearable technology and machine learning. And the reason for this is, of course, that PSP is a condition that can look like PD, Parkinson's, for several years. We know that the prognosis is very different, and it is important to be able to give people an accurate diagnosis. It is also very critical when developing new treatments and trials, both for Parkinson's and for PSP and other related disorders. And I'm focusing on PSP today for the CBD friends who are in the audience. And it has long been thought that there are differences in gait that we haven't been able to quantify very accurately and sensitively, if you like, in these two conditions. So what did we do? We looked at people who were clinically diagnosed with Parkinson's and clinically diagnosed with PSP, and we put the 6 sensors that I've just shown you. A quick recap here. So a sensor at the front of the chest that's sort of strapped, as you see here, a sensor worn as a belt on the lower back of your back, really, and two watches, one on each arm, and another 2 sensors placed on top of your feet on the shoe, as you can probably just about see them. And we asked them to do things for 5 minutes, walk for 2 minutes, get up from the chair 3 times, as you see here, and stand for 30 seconds with their eyes closed, while we were 2 of us in front and at the back of the patient looking after them in case they started swaying or feeling dizzy or uncomfortable. And what did we find after doing this? So we looked at a large number of people for both PD and PSP. And what we identified is that there were 17 distinct different gait parameters. So the way that you walk and the way that you hold your posture has different numbers, if you like. And what we found that 17 of those, especially during walking, was particularly interesting in helping us differentiate people who were clinically diagnosed with PSP and were clinically diagnosed with PD. Of course, naturally, you might ask, but you already knew that. When you enter people in the study, the fact is that we blinded ourselves and the engineers that were working with us at the beginning of the analysis, so we didn't know who was whom. And we only looked at the data as sets of data, not knowing which one represented which patient and so on. So this came about when we unblinded all our data. And this led us to the follow-up study, which was published in the Movement Disorders Journal a couple of years ago now, where we attempted now to track progression of walking of people with PSP, using, again, the similar set of sensors, 6 sensors, 2, 1 on each arm, chest, lumbar, and 1 on each feet. And what we wanted to do is see whether we could track the progression of walking and whether we could also figure out whether any of the sway numbers that we were getting could actually help us follow these patients for 1 year. It was quite an intensive study because we asked patients to come every 3 months here at the John Radcliffe in Oxford, where I'm based, using these wearable sensors. And what we try to do is use clever bioengineering techniques with our wonderful colleagues here in the bioengineering department at the University of Oxford, where together we build a computational model. And we use a very clever technique that some of you may have heard, some of you might have known, called machine learning, which looks at these numbers in different ways than what we have traditionally done with our statistics and our maths, if you like. So What did we look at? We look at all sorts of different features, we call them, all these numbers of how you walk, how you turn, how you might have the tendency to fall if you're turning in a particular way. And we really found a number of different features that were changing in this instance as the time went by and as people might be progressing with their disorder or as people were absolutely stable in their condition. And we wanted to see whether we can objectively measure how walking and balance symptoms progress with time using these digital devices. But also we wanted to assess the usefulness of this data, all of these numbers that are coming out from these digital devices against the clinical standard examination and all these questionnaires and everything that you're asked when you're seen clinically. So we found many different features. For instance, a feature is how quickly you walk, the speed of walking. And 32 of these features were identified that were really picking up this progression as the time went by. So when we try to then look a little bit closer, we wanted to see, are there any particular features, any particular numbers or sort of characteristics of your walking or your sway and so on that were more significant? And in fact, we found out that there were three things that really stood out: the toe-off angle, the stride length, and the turn velocity. And let me try and see if I can explain in simple terms what this look like when we're looking at these numbers. So the toe-off angle is when you lift your foot when you're about to take your next step, or when actually you have finished taking your first step. So this is exactly what the toe-off angle is measuring. That is proving very important, both in PSP and in other conditions using similar sort of technology. What we've also found is that the turn velocity, so how quickly you're turning, was also quite interesting in helping us sort of follow and track and monitor the progression in each one of you that have taken part in this. And the turn velocity in this instance, this is a small room, this is not where we did the 2-minute walk, was when you were asked to walk in a large and long corridor for 2 minutes. And this is exactly at this point here. I hope you can see the middle sort of video here when Lily's turning from side to side. So that was the second sort of area that looked really, really promising. And the third one is the stride length. But the stride length really is a distance. I guess the simplest way of explaining it is the distance covered when you take 2 steps, one with each foot. Okay, so if you can see me, it's one with each foot and is the distance that you cover with that. And again, it goes back to how someone is walking. I think this is tremendously important because these digital technologies and these wearables that we can send you home with now are becoming very easy, very accessible. We've had a remote monitoring at home. Some people have had some of this remote testing. Some people had the wearable technology, some of them didn't. We're just looking at the data, and I'm really excited to say that the pilot data is looking very promising. I can't share it today because we have not finished. We've got a little bit more work to do, but this is really promising in terms of if people cannot come into the hospital, they cannot come into the lab to be tested, they can be really followed up at home, hopefully, which that will be tremendous, especially for trials and for people who cannot be visiting or getting out of their houses as easily or conveniently as others. So I'm going to leave it to that so we have some time to discuss if you've got any questions. And I'm just going to wrap up by saying that I feel that technology, if used carefully, and I insist on this, that technology can be good and can be bad, and we have to use it carefully and cleverly, can help us quantify your cognition, the gait, your walking, your posture, your eye movements, your general motor and fine movements with great accuracy. If you combine some of the recordings I've shown you from your eye movements, for instance, and your general movement with the clinical examination, I truly believe it can provide a powerful tool, and we and others have shown that to date. And I do feel that wearable technology can be extremely helpful for personalized and continuous monitoring, personalized, which is precision medicine, and continuous, I mean, remote monitoring. So from the ease of your house, and then sort of do telehealth, which is what we've been doing in the second phase of our study. I think this is a very exciting time of neurology and clinical neuroscience, as we have all these advances in technology. And again, when they can be used appropriately, they can be extremely useful in understanding both health and disease. And in this case, the disorder we've been studying, progressive supranuclear palsy, and the patients we've been looking after. Just a quick thank you to all the fantastic team that is behind the scenes. It takes a team to get to the point where we are today, where we can actually start thinking about these tests as good biomarkers that can be included in clinical trials. And happy to take any questions. Again, as I said earlier, we have just opened the site here in Oxford. So anybody within the Oxford area or the Thames Valley region, please feel free to get in touch. This is my email, and I'll put you in touch with our nurse to sort of get you first seen. Any questions that you might have, also very happy to discuss. And thank you very much for listening to these, and for all the patients and their families for their tremendous support over the years in what has been a very fantastic and a very hard journey for all of us. But I'm hoping that together we'll be able to continue this work and be able to deliver something better in the future. Many thanks.
Excellent. Thank you very much, Chrystalina. An absolutely fascinating study that you've been carrying out there, and just so important. We know for research that getting earlier diagnosis is important, but we hear that from families all the time at PSPA. Whenever you visit a local support group, it is the diagnosis journey that people want to talk to you about, because it's often just been so challenging to get to that point. So all of those advances are really important. Just to clarify, when you're talking about people getting in touch, that's about the NORAP study, not about your wearable technology and the OxQuip
That's
program.
right. That's right. We're no longer recruiting into OxQuip. We've shut down recruitment. We will be having further studies, but not yet, probably in the next few months. But that's about the NORAP study.
Okay, thank you. So I've got a couple of questions so far in the box. So from Anne, I thought that falling backwards is also a pointer that you have PSP.
Yes, absolutely. And that can actually, it's a very good question, actually, because what I didn't have time to show you, is that a lot of the data that we're using during the walking is very informative if you're having this very minute fall backwards while you're walking, and you're not necessarily falling. What we call is near falls, when you're sort of having this corrective movement when you're trying to turn, when you're in the middle of your walking, and so on. And that comes out, if I can go back to one of my slides here, from this data here. So this data here can actually help us see if someone is having the tendency to go backwards or go side to side, which then can predict if someone will start falling, for instance, in the near future. And that's some of the work that we've just finished, which I'm hoping to share in the next few months with people.
So it would be a sort of pre-fall warning,
That's
is what you're
right.
saying.
That's
Yeah.
right. Yeah. Because if you follow people over sort of a year or two, which we have done for phase one, you can then have the whole spectrum of people before they've started falling. And when unfortunately that starts happening, it would then have been able to look at what happens before and what happens after, if you see in terms of the data.
Thank you. And a question from Rob: have you been able to show the differences between Parkinson's disease and PSP, and why was CBD not included?
Yeah, the only reason was, to be frankly honest, funding, because we got funded for the particular disorders we were looking at. There's no reason why we can't be extending this to CBD, and I do hope that we'll be able to do that in the near future.
Mhm. And have you been able, the first part of the question was, have you been able to show the difference between Parkinson's disease and PSP?
Yeah, sorry. Yes, we between PSP and
Parkinson's disease.
Yes. Are you referring to the walking or the oculomotor? Is there anything particular or in general?
This was just a question from Rob. I don't know which Rob it is, and if they can put anything else in the box to clarify. I guess has the
Okay,
sort of
I'll try and
data.
answer it generally. So
Yeah.
yes, we have. So for both eye movements, for the eye movements we have, but it's not specific. And by that I mean that if you've got an abnormality of a saccadic eye movement, which is the most common type of eye movements you're all making at the moment, looking at the screen, looking at what I'm saying, or your phones or your notes and so on, we have shown differences, but they're not specific to PSP. So they could be similar changes in Parkinson's, for instance, or other disorders, but there is a change. With the wearable technology I'm showing you here, yes, the difference is quite starkly different in terms of the types of numbers that are generated by someone who has PSP as opposed to someone who has Parkinson's. And that again could be reflected in how you turn, the speed that you use to turn, how quickly or slowly you're interchanging while you're walking, but also how your toe off angle that I showed earlier is sort of being picked up. And that angle is really important because people with Parkinson's, for instance, have shuffling gait as opposed to people with PSP that might not have that particular type of gait disturbance. I hope that answers your question, but whoever was, please shout out and happy to discuss more.
And a question from Kelly. Is CBD less diagnosed than PSP, as most research seems to target PSP rather than CBD?
I'll defer to Dr. Gosh for this one because I don't look after CBD patients, but I guess for research, it's very much about the funding here. We would have liked to look at all the PD related Parkinson's and related conditions for any study, but unfortunately, it's not an easy task.
I don't know if Boyd is still with us, or Rob, can you
I think
answer?
I might be able to offer my opinion on that.
Mm.
Is that observation that the focus is towards PSP. So there's two strands to why that is probably the case. So PSP is more common. It is more common than cortical basal syndrome, and as a disease, PSP has a very um, clear association with a certain type of pathology under a microscope. If we were to take a part of brain, PSP has almost 100% association with one particular type of pathology, so cell change. Cortical basal syndrome, meanwhile, has a much more variable cause of the disease under a microscope, and therefore it's a less perfect disease to study because it has much more variability within the illness than PSP does. And so I think there's two broad reasons why your observation is true. But it doesn't mean that CBD or cortical basal syndrome shouldn't be a focus of research. And I agree entirely with your sentiment that it can probably feel like it's left out in the cold.
Yeah, thank you, Rob. And we always try to make sure that there's a bit of a spread in the sessions that we do, but it does sometimes depend on what studies the places a study is in its progress really, and where there's feedback to be had. But that you're right, certainly it's less common and therefore less people to be able to study with in terms of when you need volume of numbers for people. But I recognise that that's quite difficult if you're the person with the diagnosis and wanting to see what progress is being made, definitely. Let me just check the questions, Cristalina. There was a thanks from Rob, so you did cover that, thank you. And a thank you from Kelly as well. That's the end of our questions, and we're dead on 12 o'clock, Cristalina, so perfect timing. Thank you very much for coming to speak to us and updating us, and we look forward to the further information that you'll hopefully be releasing soon
Thank
as well.
you. Thank you. My pleasure.
Excellent. So we are moving on to our next session. I'm just finding my notes. And we will be moving on to hear from Professor Kate Fleming. Kate is internationally known for her research and service innovation in palliative care nursing. And Kate is currently leading the integration of research and teaching in the new nursing curriculum in the Department of Health Sciences, bringing together world-leading researchers and teachers in education as well. And Kate will be talking to us about research in palliative care today and her experience